Hi everyone, and welcome back to our quantitative data analysis lectures. We're going to finish up our discussion of univariate statistics by exploring how to calculate dispersion statistics. Like central tendency statistics, dispersion statistics are used to describe a data set. But why do we need dispersion statistics? Well, sometimes the central tendency measures by themselves aren't enough to differentiate between two samples. For instance, look at these two classes here. It's clear from the graphs that Class A and Class B study differently. But if we look at the central tendency values, both of these examples have the exact same central tendency statistics. So how do we differentiate between the two? This is where dispersion statistics are more valuable. Unlike central tendency statistics, dispersion statistics focus on the distribution of the scores, not just the center value. So they can tell us about how the scores are spread out from one another, which allows us to better differentiate between Class A and Class B from the previous slide. There are three methods used to measure dispersion: range, variance, and standard deviation. One important thing that I have highlighted here on this slide is that all three of the dispersion statistics require interval or ratio level measurement, so you cannot do any of these calculations on categorical variables. First up is range. This is the easiest dispersion statistic to calculate, but it's also the least helpful. The range is a simple calculation where you take the highest score and you subtract the lowest score. The bigger the range, the more variance in the data. So if we look back at our classroom study habits, we see that the highest value in Class A is 4 and the lowest is 2, so our range is 2. Class B's highest value was 5 and the lowest study hours was 1, so our range is 4. By comparing the range values, we can see that Class B is more dispersed than Class A because the highest and the lowest values are more spread out from one another. The problem is that the range is like the mean in that it can be affected by outliers. Since range only uses the highest and the lowest score, an extreme value on either end is going to mess with your data. Here's our IQ table from the previous lecture video. Since position 5 is the highest and position 1 is the lowest, I take the high IQ score from position 5 and subtract the IQ score from position 1 to get the range of the data set. Like the mean, we see a substantial difference between the ranges of all three columns. Technically, they're correct, right? Because there is that much spread between the highest and the lowest values in the data set. But in reality, we know that all of this difference in range is caused by a single student's score. So it's not really an accurate look at the distribution for the rest of the student IQ values. The outlier influence is why the dispersion statistics more commonly consulted are the variance and the standard deviation. These statistics look at every score in the data set, so they're not as impacted by a single deviant case like the range is. Variance and standard deviation are calculated in a step-by-step process. Variance is calculated first by looking at the deviation of every score. By deviation, I mean the difference between each score and the average value in the data set. Once you've calculated the variance, then the standard deviation is obtained from the variance calculation itself. Here are the formulas for this. Now, as I've noted on the slide, I will not require you to calculate the variance by hand, but I do want you to understand how this is calculated. The x minus x bar shown here is the deviance calculation. You take the specific value, the x, and you subtract the average value in the data set. You then square that number to remove any unwanted negatives and add all of the deviations up. Then you divide by the total number of values in the data set. That's going to give you your variance. Variance is represented by s squared. Standard deviation is represented by s, which means that this is calculated by taking the square root of s squared. So once you have the variance, you simply take the square root and you have the standard deviation. Realistically, in most cases, the variance is simply used as a stepping stone to the actual statistic of interest, which is the standard deviation. This next part that I'm going to teach you is a simplified version of the standard deviation discussion that you will have learned in your stats course. If you need a refresher of this material, I do have some videos on my website, and of course, YouTube is always available for more tutorials. What we need to know for our research methods interest is that the standard deviation can help us identify where so-called normal data lies in the data set. In a normal curve, which is shown here on the slide, approximately 68% of the values will fall within one standard deviation from the mean, 95% of the values will fall within 2 standard deviations of the mean, and 99% of the values will fall within 3 standard deviations from the mean. This means that if we want to find the so-called normal values of the data, we can use the mean and the standard deviation to calculate a range of normal values. Again, I am super simplifying here, but this is kind of the basic principle. Back at our classroom study habit example, we know that the range has already differentiated the 2 classes, but what about the standard deviation? I told you that I wasn't going to make you calculate the variance, so I've provided it here for you on the slide. The variance of class A is 0.6, and the variance of class B is 2.4. We know that we need to square root these values in order to calculate the standard deviation. So we take the square root of 0.6 and the square root of 2.4, and we get standard deviation values of 0.78 and 1.5. Now we've differentiated the 2 classes with all of our dispersion statistics. The range is different, the variance is different, and the standard deviation is different. We can actually make quick interpretations of the distribution based on the standard deviation. The higher the standard deviation is, the more spread out the data will be. That's because we find the spread by adding and subtracting the standard deviation from the mean value. So the higher the standard deviation value, the bigger the spread between the subtracted and the added value of the mean is going to be. Now, the last part of standard deviation that I want to explain is the calculation of outliers. Remember that we've already discussed what an outlier is, but up until now, we didn't have any set definition for how to tell whether something is an actual outlier or not. We can use the standard deviation to give us a better identification tool to recognize outliers. Simplifying the graph from earlier, outliers are going to fall outside of the 99% range that we discussed. The calculation for this is x bar, or mean, plus or minus 3s, meaning 3 times our standard deviation. Always like to do an example because it's always easier to understand. So here's a classic test, the Wechsler-Bellevue Intelligence Scale. This IQ test is standardized so that the mean value is 100 and the standard deviation is 15. We can use the normal curve properties that we discussed to identify where normal IQ values occur and which IQ values would be considered irregular or outliers. Let's start by looking at the 1 standard deviation difference. Remember that this range contains 68% of the data. What we need to do is take the formula in 2 steps. One time through, we're going to use the addition option, and one time through, we're going to use subtraction option. So let's talk first about addition. If we take the mean value and we add 1 times the standard deviation, we get 100 plus 1 times 15, which gives us 115. Then we do the same for the subtraction option, 100 minus 1 times 15, which gives us 85. This means that 68% of people will score somewhere between 85 and 115 on the Wechsler-Bellevue Intelligence Scale. We can now do the exact same thing for the 95% option, which requires us to add and subtract 2 of the standard deviation values from the mean. Mean of 100 plus 2 times the standard deviation of 15 gives us 100 plus 30, which is 130. Mean minus 2 times the standard deviation gives us 100 minus 30, or 70. And so 95% of people will score between a 70 and a 130 on the IQ scale. And lastly, that brings us to the 99% range and the calculation of outliers. Doing the same as before, we take the mean plus 3 times the standard deviation, which equals 100 plus 3 times 15, or 145. Then 100 minus 3 times 15, or 55. And that's going to give us a range of 55 to 145. So 99% of the people who take the Wechsler-Bellevue Intelligence Scale are going to score between 55 and 145 on the test. So now that we know where the normal scores are, all we have to do now is identify those scores that would not be normal. In this case, anyone who scores below a 55 or above a 145 would be outside of the 99, so they would be the outliers. On a test question, what this will look like is I may give you a hypothetical score, and then ask you to determine whether or not that score would be considered an outlier. All you have to do is do the calculations on this slide to figure out what the mean plus and minus 3 standard deviations is, and then identify whether the score that I've given you fits into the normal range or is outside of that. Any score not included in the 99% range can be considered an outlier. All right, well, that concludes our discussion about dispersion statistics. In the next lecture video, we're going to discuss the different ways you can analyze and visualize multivariate statistics.